So integrated proc support, IPS elements and proc support. Ultimately, for folks and for the students, really the right place or right parts, right place, right time, and right cost is really sort of a colloquial good understanding of how we sort of take and operate that. Some folks will say the right quantities as well. I personally roll that into the right parts.
Okay. Okay, welcome to the SOSE Masterclass. In this lesson or podcast, we have Jason. And Jason, thank you very much for joining. And tell us a little bit about your background.
Hey, Connor. Yeah, thanks for having me. Jason Thomas. I'm a system engineer, and my current position is the director for digital transformation for the Naval Air Warfare Center Aircraft Division here in Maryland. I support the U.S. Navy in a broad range of digital and system engineering type areas, and really happy to be here. So thanks for the time, Connor.
No worries. So tell us about how you got started in systems engineering, Jason.
Yeah. So formally in 2012, I moved from sort of the domain mechanical engineering, aerospace engineering area of my organization to the system engineering department. So formally took a position in billet in 2012, supporting a program office doing lifecycle system engineering work. I would say informally, probably a few years prior to that, maybe the 2010 2009 timeframe, where I started picking up just more responsibilities and started integrating a lot more things outside my normal like scope and work with architectures and frameworks and requirements, and like this is kind of fun. Didn't know it was called system engineering. Didn't know what really system engineering was, but that's kind of what I was doing. So sort of the informal, and then figuring out and understanding what this domain and discipline really is a little bit later on.
That's really interesting. I love how like so many people that come across like just fall into systems engineering and it's like, oh, what's this really cool way of doing and delivering products? Oh wait, it's called system engineering. That's really cool. That's so what industries have you worked in? Have you predominantly been Navy and defense focused, or have you worked in other industries?
Yeah, really Navy and defense focused for about 20, almost 20 years now. I've done some work on defense side with our Coast Guard, our Air Force, our Space Force, and the Army as well, but really in defense and aerospace applications. I have had some external, what we call rotations with industry partners,
Mm-hmm.
but again, still in the defense and aerospace sort of focus, all on my civilian side. On my military reserve side, I've crossed over in different warfare domains beyond sort of the naval maritime area. So
Very good. A very illustrious career, I bet.
uh,
It's really,
it's fun. I enjoy it. I'm probably one of the luckiest guys around, so I shouldn't be as fortunate as I am. So very
yeah,
blessed.
very good. One quick thing, Jason. Could you tilt your camera down ever so slightly so we can get like your shoulders? Is it in? Yeah, there we go. Perfect. Is that okay?
There
There
we
we go.
go.
Perfect. Um, cool. Okay. One thing actually I'm really interested in is you spoke about digital transformation, right? So tell us a little bit about that. Are we not transformed already in the digital world, or are we still stuck in
Uh,
a model or a document based approach?
oh yeah, this is oh man, we could do a whole separate podcast. So we're so digital transformation as a field, as a discipline, as a scope has a lot of different sort of interpretations and focus areas, right? Depending on your perspective and your viewpoint, and that's good, right? Diverse focus and experiences is awesome, and we want that. Um, if you look at industry and papers and research and other things, there's not a real good firm definition of digital transformation, sort of agreed upon across different disciplines, and that's probably fine to a large extent. For us on our side, uh, so system acquisition lifecycle. So we talk system development lifecycle, SDLC. System engineers, we think of the V diagram from requirements, decomposition, um, allocated baselines, integrated test, and then fielding, and then sustainment. What we're doing on our side is really integrating a lot more of the mission engineering and mission focus, plus all the the elements that help drive that mission scope and what we need from a defense standpoint and on the Navy side. So
Okay.
what do we know? What do we think? How do we integrate all of that information together into the life cycle of developing a system
Hmm.
and building and support? How do we have the good feedback loops so we know, okay, what I delivered, am I hitting the mark? Are we not hitting the mark? Um, as well as on the business side of things, how are we transforming our business to integrate with that?
Hmm.
So, for example, if we look at like talent management or like workforce development, critical area is really key. Um, how do we integrate? I need more systems engineers, or I need more AI and ML type folks. I need cyber warfare type folks or network engineers. What's the demand signal? If I know certain, certain work is coming down the pipeline,
Hmm.
we can be ready for that because we know it's coming and we
Mm.
know how long it takes to do this. We know how long it takes to do that. I know how long it takes to train. What does our training pipeline look like? Does it change from what it was 5 years ago, 10 years ago? And we started off the conversation with, you kind of fall into systems engineering in some cases. Well, we want to be more proactive and not um, have these things sort of pop up, sort of happy coincidences. We want to be more proactive, and how do we really drive towards that? So how do we really integrate that together in a framework that really helps us
Yeah.
transform business and how we think, act, and operate differently?
Okay. That's really interesting, especially in the context of what we're talking about today, which is integrated product support, right? Actually, I've got so many other questions I want to I want to ask right now, but I'll hold off. So, okay, let's start at the top then. Okay, so what in your mind is integrated product support? And I'm really interested to hear more about how the mission aspect comes into it as well, and how you
Yeah.
use that. So, please tell us.
Yeah. So integrated proc support, IPS elements and proc support, ultimately for folks and for the students, really the right place or right parts, right place, right time, and right cost is really sort of a colloquial good understanding of how we sort of take and operate that. Some folks will say the right quantities as well. I personally roll that into the right parts. Um, but really looking at all the IPS elements from a product support standpoint. So, and again, as an engineer, it's like, what is product support? Oh, it's parts.
Hmm.
It's what else is it? So, and I don't think a lot of folks realize, especially on the engineering side, 12 integrated product support elements, um, um, program support management, design interface, maintenance planning, support equipment, training and training support, facilities and infrastructure, manpower and personnel, um, IT systems and continuous software support,
Hmm.
tech data, supply support, um, sustaining engineering, and then PHS&T, so package handling,
Wow.
storage, transportation, if I remember them all.
Wow.
So
Yeah, you
all
actually
those.
remembered all 12. That's pretty
I,
incredible. There must be an acronym. Was it? Is it tepid oil is what we use in the UK.
okay,
But what
that
you
one.
must have an acronym for remembering all that, surely. If it,
We have an everything. Sadly, we don't have for that. I did a
wow,
lot
that's
of study
impressive.
prep, lot of study and prep for your folks here
Yeah.
today. But a lot of folks sort of fall back and say, okay, well, it's it's parts, it's supply, right? Something
Hmm.
breaks, I need product support. Well, to support my product, I need more stuff.
Hmm.
Uh, and the best way I explain it, and I'm a big car guy. I did a lot of things in defense, but I'm a car guy, sort of hobbyist. Um, and you look at it, right? You're going to buy a new car or a truck or some vehicle, whatever it is. I want tech pubs. I want tech data to understand, oh, the right PSI for the tires. How do I integrate and how do I support my system?
Hmm.
What training do I need to service my car? What modifications can I do? Or where's the parts store? What does the parts store have if I'm doing that work? If I choose to go to a shop or a dealer, where are they? What do they charge? What's the skill level of the mechanics doing the work? What diagnostics do I need? All of that is integrated product support, and we sort of take it for granted of, well, it's just my car, and I'm going to do whatever I'm going to do with it. But all that is dedicated, specific discipline to integrate all that stuff together. And if those, if you don't know or don't trust the mechanic to restore your vehicle back to a foundational um, you know set of performance, Well, that's sustaining engineering. I'm trying to restore back to what I bought. Um, I trust they have all the diagnostics. I trust they have all the tooling. They have the right skill sets. How do you work and integrate all that together?
Mm.
Because when you need something and you're trying to go online to find a part, or I need a YouTube clip to find something. You know what you need, but if you can't get it, that's integrated product support.
Yeah.
That is supporting your product. It's customer facing. So important.
I love how you've chosen a relatively simple example of a car, right? And you've just spoken about 5 minutes of like things on how you need to support that car, which is like a simple system. When we go into the world of like defense systems, which are all integrated and highly complex, like it's just insane, isn't it? Like the levels of complexity, how much extra additional work it requires from an IPS perspective, right?
Oh, completely. There's regulations, and there's interoperability with certain things. There's the I have to um, on the state side, I can build and supply and design certain things in certain states because of regulations of that state.
Mm.
Then I have federal regulations. I have interoperability with different ships or aircraft, or things like that. All that is so critical. Um, right? If you're again the Navy, if you're on a ship, I want to make sure the ports that I visit have the right interfaces, so to speak,
Yeah.
just just to connect with. I have to have fuel, or
Yeah.
connectivity. All that is proc support, is systems engineering, really all together in a sort of beautiful, harmonized kind of way.
I love that example again. It's like, you when you think of a ship, right, you're like, oh, well, an interface isn't necessarily going to be, it's going to be an electrical interface. It's not going to be like the dock that the ship goes into, right? You don't think of that from, it's not obvious, I know it's your job to think about that from an IPS perspective, but like that is not an obvious thing. I think when you're engineering, you're tasked with, okay, build this system on a ship. You don't think about, well, that ship has to go different places, and then here's all the key interfaces that need to be, supplied to that ship to maintain it. That's a really good example. So okay, so where do you even begin? Where is a good place to start with IPS then? Like how do you, if you're a new engineer coming into the discipline, like, what's some of the key thoughts and processes for that?
Yeah, so my biggest recommendations I would have for new engineers trying to really understand the space. One, in a simple way, there's sort of the formal academic side of, okay, here's my 12 IPS elements, or whatever the organization that you join has and how they define it. So familiarize yourself with that first and foremost, right? Sort of the academic background type side of it. Then understand the customers that you're supporting, the product that you're putting out, or producing or designing. So now you have the practical sort of agnostic academic side. You have the context of the systems that you're developing and you're working on. You understand then the customer base and consumer base of those products and services, and then really pairing up your logisticians, or your product support engineers type folks, your system engineers and other folks together, in this really collaborative kind of way, to really either whiteboard or talk things through and say, how would you do this? How would you do that? I would say that's, um, I mean, that take months
Yeah.
of, again, everything else, but that really engrosses someone into to orient themselves on, you know, what do I need to know? What is it that we do, and what
Mm.
outcomes we try?
Yeah.
That's probably the first and foremost foundational, whether you're in defense or private sector or whatever it is.
And do you use any like particular mental models or perspectives in trying to understand, systems from different views that then might help elicit that information? So, if you're trying to think about it from a particular way, do you have anything in mind that you say, okay, well, think about it from this perspective, or think about it from this perspective, which then might kind of bring more ideas about how you'd engineer that system to life?
Yeah, so we'll do various working groups and things like that. So if I'm building a ship or an aircraft, you, I think what's important for any new system, and again, it could be an iPhone, could be a computer, could be whatever product that you're putting out. Understand the current products and services that you have, and then say, okay, um, this aircraft serves this purpose. It does this mission.
Mm.
Mission change. Does the consumer base change? What's our understanding 5, 10 years ago? So you have context for your reference point. Then when you start looking at, I need a new ship or new aircraft or whatever it is, you can then say, okay, well, we did this or we thought this 10 years ago, and this is why we did it this way. Do those same assumptions apply? And then sort of walking through and say, okay, I have maybe I have unmanned aircraft systems now. Before it was my uh, a co-pilot or a wingman that
Yeah.
was manned.
Yeah.
Now, how do I interface with that a little bit differently? So same use case of say communication and then navigation and then aviating, but how you do it is a little bit different. The
Mm.
systems, electrical interfaces, RF interfaces, whatever it is, maybe a little bit different. Um, Now, how does that then translate to a product support standpoint of, oh, I need, right? If I'm at an airport and I have someone sort of doing the lights and driving directing the aircraft, well, I don't have that in an unmanned system now. So do I have a support piece of support equipment that's a little bit different
Yeah.
that then helps fulfill that mission of maneuvering that aircraft,
Yeah.
um, or things like that? Am I
Yeah.
maintaining locally on ship? Am I at a depot? What do I assume I need and what do I actually need? So you can take a lot of the same use cases,
Mm.
um, refreshing, um, and not sort of assuming away like, oh, we did this before, we did this before, because
Yeah.
it's good, but it may not apply.
I suppose it's very rare you're ever starting from scratch, and even on R&D programs, right? Actually, it's very rare that it's a complete blank piece of paper. The mission has probably been defined or it is similar to something that you're applying, and I like the term mission because mission doesn't necessarily mean a defense mission. Actually, the mission can mean anything. It can be a car. The mission is to transport people in a car, right, or something like that. That's the mission. So yeah, I like that concept of understand what the mission of the product is and then actually look at that from a different perspective. In particular, then how you applied the use cases for that unmanned vehicle, like ground maneuverability. That's like a use case of that
Yep.
mission. And when you take the man out or the human out, you break the use case and all the current implementation methods, right, that we currently have for maneuvering with the guy in the lights and the sticks and all that stuff to help maneuver that aircraft. It's like I like how you've actually given a really good formal mental model of how you can actually maneuver that, kind of think about that with the different mission and then use cases. I think it's a really, really nice way of framing it.
Like,
Yeah, no, that's good. Okay, so how do we design as engineers? And so system engineers are really guilty, I think, for actually not thinking about and incorporating IPS very early on in the design lifecycle. So where do we begin as system engineers to really start thinking about IPS?
yeah. So I guess I'll give two examples. I think so. I've told folks when I run programs, I work to ensure my system engineer sits very close to my product support manager or whoever my head logistician is or whoever owns the product support side of it. Um, because even if it's right, you're in the office and you have a phone call and so and so says this, so and so says that, and people aren't eavesdropping, but there's great conversations that sort of happen. Like, oh, I heard you say this to Connor on the phone about some design element. Well, if you do that, this is what's going to happen. Like, oh, I didn't think about that.
Mm.
So having folks co-located in a sort of shared, sort of area close by facilitates and really helps that. It also then sets a good premise and a foundation for junior folks as they come in and they see, oh, my engineers, especially system engineers, sitting right next to my product support engineers and my logisticians and other folks. So it's not, someone's on one side of the building, someone's on a different side of the building or different office space or whatever. It is, we're in this together, we're delivering some product to fulfill some purpose, some mission. I think that's one thing. Um, One example I'll use is one of my friends, Jared, who taught me this years ago, and he used the example of an Apple laptop. And he said the engineers are gonna right there's like screws in the back of the laptop for holding the case together. He said the engineers are going to look at that and say, okay, I'm going to use some great FEM analysis and design these screws and it's going to be great. It's going to have this great strength, and you're going to save a fraction of weight with these new awesome screws that are perfectly flush and awesome. Then a design interface practitioner will say, well, that means that's a different piece of equipment that has different tooling that is not in the supply system. That how are you going to then support that if it totally breaks the supply chain of things? Or you're now stocking a bunch of these screws or tools at the Apple Store or whatever that only a few people are going to use. Like, why would you do that? So understand what is already out there. Um, what can you leverage that's already in, say, the supply system,
Yeah.
or what are good designs already? And if they're prolific, if the design is prolific and they're bad, then start make that better with a new design, and that's great. But um, don't over engineer something without understanding the implications of what that means to, say, the end user or the logistician or IPS engineer that has to then do a whole bunch of other work. So that was a great example that he taught me probably 6 years ago now.
Yeah.
And I think one other area that I'll hit on that I see quite a bit in my domain, um, reliability and maintainability. So in our organization, R&M engineers, or engineers that do that work, it's reliability and maintainability. A lot of focus on reliability um, over maintainability. And when we talk to our folks, a lot of these system engineers and senior folks will say, "Oh, reliability is a logging thing, or it's a logistics, proc support kind of thing." It's like, no, you own that. Like that's an attribute of the system. That's
Mm-hmm.
part of the design that is going to have a ramification, and maybe offers a constraint or some trade space of the design, from a holistic standpoint for proc support and other folks.
Yeah.
So it's not just, oh, it's reliability, and if it fails more, that's a supply support problem. We can do things in reliability and design and smart things, hopefully,
Yeah.
to make it fail. Right? I go back to the consumers, right? I don't want I don't want my car to fail or break or my phone to break or do these things, and I just buy a new one. Like that's not. No one wants that.
Mm-hmm.
Um, so um, how do we reframe things that we've taken and approached traditionally and say, okay, why do we say, why do we have these impressions and viewpoints of attributes, say in reliability or
Yeah.
some other area, supportability or safety? How do we integrate that a little bit better, kind of going forward?
I like how the concept how they're really closely coupled as well. Like reliability. If you don't have good reliability, then you really need maintainability as like the very close cousin or brother or sister that will help with your reliability, right? To maintain that kind of reliability, and then obviously you have the third part, which is the availability and how
Yeah,
actually the maintainability might actually affect the availability of your system and its mission. It might not be available for the entire time it's needed, and so on. So it's yeah, it's
it's
really
great.
difficult.
Yeah, and I'll emphasize for folks, right? Everything's a trade space, right? The program team owns that trade space. If something fails, is it a catastrophic failure or is it a some built-in test thing? Some little light comes on, you just have to reset it. I may not like it, it may be a nuisance, but it's way better than a more sophisticated design change that ends up costing my system
Hmm.
or costing the consumer twice as much, or at some point there's right knee in the curves and design utility curves and other design parameters that we want insights to. Again, sort of going back to the digital transformation type work, having that insight across the portfolio of domains and skill sets really helps bring that to light. It's like, oh, I didn't know that.
Yeah.
If I knew that, I wouldn't have done that, or we would have advised differently. Just having that at someone's fingertips and that awareness is huge.
Hmm. So so you spoke about essentially having people in the right sort of space, having people think about the core tenets of that kind of R&M and our RAM facets of so they're good skill sets. Is there any other particular good skill sets or thoughts that an IPS engineer should have or potentially some training that they should be aware of, or is there what makes a really good IPS engineer?
Uh, I'm a big fan of cross training, sort of in general. So
in the
familiarity and
in the
awareness.
gym, not
Yeah,
not
yeah,
not
yeah.
cross trip in the gym. They're different.
Yeah.
Yeah.
But right, so but it's right. So great example with like fitness is like if how do you define fit? Okay, well, if I'm a runner, I run, I don't know, 10 miles a day or whatever it is. My my body is going to be conditioned for that, and I may not have, muscle strength or endurance in other ways. Or from a power lifter, I'm going to train in a particular way that's going to optimize me for, for one thing. Ideally, in cross training, you have sort of this, jack of all trades
Mm.
sort of approach, because it's just dynamic, right? Things happen, contracts happen, funding changes, program changes, all these things happen, and you want to be proactive and aware, what could happen and design changes or what have you. So I'm a big fan of cross training, especially in systems engineering, especially in product support engineering and work. Um, the I think if you're in our organization, we have logistics element managers, LEMs, that maybe focus on supply support
Mhm.
or support equipment. I think having folks uh, cross training within the product support elements is really important. So you know the coupling and what happens, and if I do this over here, this happens. Um, Same thing on system engineering. I talk to mechanical engineering, electrical engineering, avionics folks, whoever, from a good system engineering standpoint. Now, if we can really get more cross training at the right level, because you still want SMEs, you still want people experts in their areas,
Yeah.
but where you can get smart cross training for the things that matter, say in early acquisition to product support or systems and support, so oh, we're having these issues or this is going well. How do we leverage the best of both, um, and start infusing those designs a little bit better? So I think that's really important. And then I'd say other good skill set is um, the willingness to learn, and the humility to say, "Hey, I don't know this," because that is critical, especially when you're doing cross training or you're sort of stepping out of comfort zones. There's going to be a ton that any of us don't know. So I think just um, coming out with um, that openness and wanting to learn, and that sort of inquisitive nature, I think is critical and foundational.
Okay, so that wraps up what some of the good things in that cross training piece and the necessary behaviors. What are some of the traditional mistakes made in IPS that are worthwhile considering and being aware of? Then.
Yeah, I think so I think folks within systems engineering understands that I'm engineering a system and it's multidisciplinary or transdisciplinary, whatever the INCOSE, I think it's transdisciplinary with the INCOSE definition today. Um, there's not a real there's not a definition like that on the IPS side. On the IPS side, we really talk about that it's integrated and it's a lot of different aspects and elements, but we don't. We talk about integration, but I think that's an area that's still, to my estimation, sort of struggling with. Um,
Mm-hmm.
Integration could be I have my 10 LEMs in a room, but are they talking to one another? Do we understand that, hey, when I say this is going to be the implication here, and what those coupling and crossing over points are, what those pain points are. I think that I would offer. I think that has to be an area of focus for the community to really
Yeah.
sort of drive that.
Yeah. So, what's the difference between product support and integrated product support then?
I would say neither.
Okay.
I
Yeah. It's
a part of that. I mean, people could say, well, I'm supporting the product. I'm supporting the product. I'm providing you parts. I'm providing you stuff.
mm-hmm.
Okay, how do I take my tech data, my pubs, my instructions with the right tools, the right skill sets, um, positioned well with right support equipment, maybe the jack stand for my car or whatever. How do I integrate all that together and know that it's going to work? And I don't have a different bill of materials. I don't have a different instruction, a different version, or different software. Like
Mm-hmm.
I can provide you. It's sort of a fire and forget. Like, hey, I told you. Well, you told me, but a truck was going by or my kid was screaming in the background. You sent the message. I didn't receive it. So
Mm,
you can support it, but support is sort of open to interpretation. Um,
yeah.
and then I think the integrated part of that is I'm talking to Connor, who's an expert in system engineering. Uh, is he integrating other aspects of things that I care about and I need to know? Or am I putting a lot of weight on the person from their perspective, assuming that they're integrating it and providing that recommendation to me? So there's some assumptions, and, going on faith in some cases that, we can probably strengthen a little bit, my opinion.
So how early does IPS come into the picture of systems engineering in terms of design reviews? Where do you actually start reviewing the outputs of IPS in a product development lifecycle?
Yeah, so I mean, early and often, the challenge we run into is if I'm designing a brand new system, say a new aircraft or a new ship or whatever, new car, new computer, um, I can support a thing. I can support hardware. I can support a computer with tooling and screws and tech data and all that. Um, so that's traditionally, I think, where people start ramping up the IPS work. I would say even earlier of okay, how again, sort of those operational use cases, those mission threads, the
Yeah,
okay, who's going to be using it, how often, in what conditions, um, what environments are they? Am I taking my laptop? Am I taking my computer with me? So now I
yeah,
need a portable computer, and am I taking it on a plane? Am I taking it? Where am I going? So we know just human systems integration type elements that cross over between system engineering and proc support.
yeah,
Maintainability. I think there's a lot that can be done early. Say say milestone A, pre-milestone A, even analysis of alternatives phases early on that could and should have more proc support integration
yeah,
influence early on, especially when we talk about right the supply posture, tooling, what's already out there. If it works great and people are familiar with it, then great. It's familiar, right? It's the your phone app store or whatever. It's familiar. It's known.
yeah.
If it's terrible and it's already out there, then maybe that's an opportunity to change something about the interface or the support that's being provided to the consumer. Um,
So,
so dialogues is important.
so I've often sat in design reviews where I would feel like if I mentioned, um, product support in it, I'd kind of get thrown out the door type thing. So, what, where, where, because you are so early in the design process that like some people are just focused on what they see and right in front of them as opposed to kind of what's going to be needed in 25 years type thing if it's still going. Is there a way that you could essentially evolve, or do you prioritize like key facets at the very beginning in the early stages to say, okay, well, at the very least, you need to be considering this at this prelim design review, and then gradually evolve that IPS capability like throughout the design lifecycle?
There are. We actually on our side we have a set of reviews, so system engineering technical reviews, and we have a set of go bys or checklist or guides for folks to say at this point this should be known or should be discussed. It could be
Yeah,
anything program management type things, could be system design and requirements volatility, architectures, any of that. At some point, you need okay, how are we going to support it? I need how many levels of maintenance, for example, right? Organizational, intermediate, or depot level sort of support. Um, can we do that? Like, do we have the right enough people? Do we have the right locations for a new aircraft coming off the line? Um, one of the challenges we do have is right. I can't if the system is in flux, right? If I have requirements volatility because of some whatever it is for whatever reason, then I can't do allocations properly. I can't. Maybe I can get functional
mm,
decomposition. Maybe certainly, right? Allocation is going to lag behind that, and everything else. So um, how do we understand the maturity of the system at a point in time, and then say, okay, here's 5 different courses of action or 5 different COAs that are going to happen, and then how do we, um, here's some things to consider if we choose to do this kind of support or this kind of training or this kind of whatever. It's a tremendous amount of work to do additional, because it feels like additional work to, that may be rabbit trails for different courses of action to support, but they're important. So how do we, and it may be, right, quote unquote, I don't want to say wasted work, but it may be an investment that is not, seized upon later on. Because
Yeah.
it's work that has to get done to support it if we choose this, if we choose that. And I think product support and IPS has a key role in that trade space evaluation, in that co-evaluation. Beyond I'm building a new computer, I'm building a new car or truck or aircraft or whatever it is,
Yeah.
beyond the technical specs side of it.
And trying to bring it as early as possible into the process. Yeah.
Yeah, and because I've seen design reviews where the loader stations will get not shouted down, but sort of dismissed, and that's um, it bothers me when I see that, and I pull people aside later on and say, hey, I think people don't understand the implications and the concerns that are being brought up. And again, it's a two-way street. Um, the system engineers and folks have to understand what the product support team is saying, as well as when the product support team has to communicate the certain aspects of design that may affect. So, right, it's a two-way street. Just because someone's saying something and not being listened to doesn't mean that it's ignored or not valid or is valid.
Yeah.
Right? There's a pairing there that has to match up.
So into your day job then, digital transformation and IPS. So what is it all about? And I do want to come on to the topic of AI. There's a really good paper just come out now recently from the IET on how we could use AI and IPS type stuff. So really keen to understand more about that. So how do you go about that digital transformation piece? And you're employed, right? So you have lots of work, I guess, in doing this sort of stuff. So what's it all about from that digital transformation piece?
So the digital transformation and the IPS sort of integration, or
Yeah.
yes,
Yeah.
yeah. So I actually have two papers that are going to be presented next week. One is sort of workforce development, digital transformation focused, with the premise being um, uh, when we talk digital transformation, at least in DoD and sort of on the US side, a lot of focus is on digital engineering. So system engineering, MBSE, maybe some test, and then some design and manufacturing focus. And then supply support, product support is not forgotten about, but it's definitely minimized. And the training, therefore, is then lagging. And what does that mean? Like, how do I, as an IPS engineer or product support or a LEM or whoever, what does that mean to me? How do I see
Yeah.
myself in this digital transformation sort of monster that's coming down the pipe? That's one paper, and the other one is looking at investments and how do we make investment decisions leveraging digital transformation. Again, sort of the systems engineering focus of, if I change something over here or invest in over here, is it going to yield a benefit to the organization, to the program, to the consumers? Down,
Yeah.
down. How do we work that? Specifically on product support. So I think one of the challenges we have as an industry is, I think, despite all the papers and research and things that are out there, a lot of folks will still focus on IT and tools when they talk digital transformation and even digital engineering. A common mistake I see, or misstep I would assert, is digital transformation equals digital engineering equals MBSE, or maybe FEM or CFD or some of those. It doesn't talk about the analytics, doesn't talk about the feedback loops, doesn't talk about the standards, the data transfers, the architectures, all
Yeah.
that, the workforce development, the change management, all that work is part of that monster. Specifically with product support, we tend to boil it down to, oh, it's a product lifecycle management tool, a PLM.
Mm-hmm.
And there's a couple different vendors out there. They're all good in their own rights. Um, so okay, now I'm using a tool. Is that really digitally transforming? And actually, one program that I supported a couple months ago, one of they had a position description for a proc support, digital proc support loader station, I think is what it was called. And then there was a phrase of, we'll use digital tools. And I asked them, I said, so what does that mean? Because what tools do we use right now that are not digital? right?
Yeah.
So whether it's the software or whatever it is. So, okay, what do you mean by that? And then you start unfolding and understanding use cases a little bit better. What's a day in the life? How am I right landing on an aircraft carrier? How am I taking off from an aircraft carrier? What maintenance do I have to do on an aircraft carrier? What are the whatever your operational context is? And is it all tool based? Is it or are there other skill sets like architectures, like more in-depth, involved requirements definition, more precision,
Yeah.
um, semantic definitions, and things like that that are needed from a workforce development and skill set within the product support community to then converse and then highlight, well, this is what I mean. Because again, that crossover between system engineering and product support doesn't happen too often.
No.
One of the few my organization that does and that has done it. So you can sort of hear these conversations. Um, so from a digital transformation standpoint, right, that's when you're putting it in models. That's when you start realizing like your model's all screwed up. Like
Mm.
you have Connor said this over here and Jason said this over here, and we're in a meeting and it's totally good and everybody's nodding up and down. You put it into a model, like, oh, that's not right, you know,
Yeah.
because you're formalizing it,
Yeah.
architecture, and you start seeing where things don't line up, or there's mismatches, or assumptions, or any of that start manifesting. So how do we get past that? There's a foundational piece that sort of we have to ramp up to, and then the model is just the formalization of things that we've been doing.
I like that. The formalization aspect because it's almost as if in the traditional document based or whatever we are in right now, um, it's as if we haven't necessarily formalized it unless it's like written down as a sentence in a document. And even then, there's probably lots of opinions, but it feels like as a model based approach, we're trying to like formalize that understanding and make it common across organizations, but it feels really laggy. It feels like we're not getting there. And if anything, over the last year or so, we're like taking a step backwards away from it because it's a big, unsightly beast to transform a whole organization into a digital based, you know, giant, especially in defense, which are just humongous projects, right?
It's a monster, and I've told folks because when I describe sort of my role and my focus, or the what the scope is, truly what the scope is with the digital engineering, the business, the all those kind of things together. Pulling in experts from workforce development and other folks, uh, and like yeah, that's a monster. Like it is, and it's probably a herd of elephants, and you don't
Mm.
eat right. You don't eat all the
Yeah,
elephants at you don't
yeah,
eat the whole elephant at once. But if you don't properly define the scope and right, define what you're going after and what it is, then you don't really know where to begin, and
mm.
you don't value stream the value chain of what to do first and what's predicated on something else. I could
Yeah,
start over here, but if I do something here, am I, unintentionally adding a constraint where I don't need to?
mm.
Or hey, we just need something to help people with whatever policy or something else, some guidelines, some training. Go take this class, whatever it is. I need something. Okay, that's a sort of a risk reward. We're not sure if it's going to be, we don't know if we're going to keep that class next year or in 2 years from now, but it's good enough for right now, and it will help us solve this.
Yeah,
So, right, it's sort of this unwieldy beast that we have to sort of really get around, especially on something like defense, and we have integrated and interoperable systems between say Navy and Air Force and other Army. Um, those standards have to be understood, so we design interoperable open architecture type systems
yeah,
to they work properly.
yeah. It's a journey, right? It's like don't eat the whole elephant. Start by the tail type thing, and gradually work your way. Yeah. Okay.
Yeah.
Okay. Then the biggest elephant in the room of all, then AI in IPS. You know,
Okay. Yeah.
what's happening? You know, where's that going? Where's that going to lend value to it in the near future? Where's it just going to complicate things?
Yeah. So this is a fantastic topic. This is probably at least a couple follow-ons or something.
Yeah.
Um, So there's tremendous opportunity, I think, in the, what work do we do and what outcome does it achieve in terms of any of the product support type things. Because I can take each individual IPS element and say, it's important. And we can all agree, yes, it's important. But is there a particular weighting behind what's more important, or what has a particular is more critical to mission success of a helicopter, or a sedan, or a minivan, or a tank, or a ship, or whatever it is. They're all important, but certain ways that we operate and we design our systems, one or a couple maybe contributing more or less to the success of that system.
Mm.
So I think AI is tremendously helpful in that space. Um, there's one of the challenges we have from a funding standpoint and from a supportability standpoint of the work. Here's my org chart. At some point, I needed 10 people to do these kind of work to support that system, and they're producing some product or whatever. We do have tremendous insights into, okay, how many things are being produced, what's the effect it's having, and at some point, do we have sort of this diminishing returns that we can say, okay, the knee in the curve is such that I can throw more money at it, or more people and more time, and it's really not going to make an appreciable difference. It's better if I apply those resources elsewhere.
Yeah.
I think that's really important. I think the supply chain and supply posturing is critical. I think there's a lot of work that needs to occur from that standpoint, and not just sort of regression models.
Mm.
I think there's tremendous learning there. About 3 years ago, I was part of a AI for defense and model and sim for DoD effort, and there was amazing work going on in that space. Um, and I think we just need to accelerate that more and really put focus in that area. And I think product support and IPS is ripe for
Yeah.
and yearning for that kind of insight.
I think there's a lot of low hanging fruit, isn't there? In IPS in particular, like you spoke about regression, right? We could literally use regression to look at failure modes and reliability and all that sort of stuff to just say, okay, well, we know it's got a lifetime of this, and we're going to need a predictive maintenance event at this point in time, based on a regression model. So it's almost crazy that
Yeah,
we're not using that on a large scale, right? But
yeah. Even like if I right, it's a like I'll say like so maintenance practices. At some point, like my pub says do these things or do these steps. At some point, if I'm going through the step and I'm checking off what I'm doing, we can optimize that, no doubt. That okay, don't do steps 5 through 7. You can go from 4 to 8 without any loss of whatever.
mm,
Or every time we do step 8 for some diagnostic or whatever it is, it's not yielding the results. We can get those insights just by, is this what you were searching for? Is this what you were looking for?
mm,
Did this solve your problem? Same kind of thing that we see on any website. Was this tip helpful?
yeah.
You type a question of something. Was this page helpful? Yes or no? Same kind of things we can do on the maintenance practices side, and a lot of other areas as well.
Yeah, that's really exciting. Okay, wrapping up and looking at the big picture of IPS and kind of closing thoughts. Any final thoughts to share with beginners, or lessons learned on what IPS is all about and how to kind of adopt it into your everyday thinking?
Yeah, so I think the one of the biggest things I'll highlight for folks is, right, product support and IPS is really the customer facing, consumer facing side of your product. So if you want your customers and your consumers to have a good impression of your brand, that's what they're going to see. They'll go on a website or somewhere to buy a car based on, or a computer based on specs, right? Performance, off-roading, whatever you care about. They live with the product support side of it, right? If it's reliable, if it's maintainable, if I can use it, if I can interoperate with it, if I can get help, support, whatever it is, that is all IPS.
Mm-hmm.
So I would stress for your folks, um, just in their day to day, if it's a computer, if it's their car, whatever it is, their stove, their oven, whatever it is, look at those product support elements in the same way that you're interacting with and interfacing with those products and services, and say, okay, am I providing the level of satisfaction to my base that I would expect and that I would want? And do my folks have a good, or do my consumers have a good impression of our brand, whatever our brand is, right?
Yeah.
So And from that standpoint, and then how do we take a systems engineering approach to IPS and integrate those elements better in unto itself, and how do we integrate those with system engineering and other disciplines more and more prolifically um, in different, across the board. I think is critically important, and just the communication, right? I think it's understanding. You said this, I meant this. This is why it matters, and just again coming forward with some humility and understanding. We don't know everything, and we want learning, and that's the only way that you're going to get there.
Okay, that's actually amazing. Thank you very much. They're really good closing tips. Well, thank you very much, Jason, for coming on and speaking about IPS. I've actually learned tons myself, so that's always a bonus. So I'm really enjoyed it. So yeah, thank you very much. Really appreciate it.
No, thank you, Connor. This has been a great experience, and I'm very thankful for the opportunity.